I'm going to start with a sentence that sounds insane, but one of the most respected physicists alive takes it dead seriously. Ready? There is no real state of a particle. There is no what's actually happening out there. There is only what's happening relative to something else. And the wild part isn't that it sounds crazy, it's that it solves a problem nobody else can solve cleanly. So stick around. We've all seen 1,000 videos about Schrödinger's cat, Copenhagen parallel universes. They're fine, but those are interpretations from almost a century ago. In this series, we're not doing those. We're doing the hot ones. The interpretations from the last few decades, the ones dividing physicists right now, the ones that start real fights at conferences. And I'm not just going to tell you what each one claims, because that's the easy part. I'm going to show you what problem each one solves, since that's the only thing that earns a theory a seat at the table. We start with the most elegant and the most disturbing of them all. First, the problem every one of these theories is trying to kill. Before you measure it, a particle isn't sitting in one spot. It's in superposition, a blend of all the possibilities at once. That's not philosophy. The math says so and experiments confirm it. But the instant you measure it, you get one single result. And here's the genuine problem. The equation that runs the universe, Schrödinger's equation, never produces that result. It only ever describes the smooth, spread-out cloud. The collapse to a single outcome simply isn't in the math. So when does it happen? What counts as a measurement? Why is the cloud allowed for the particle but not for the cat, or the detector, or you? Every interpretation is basically a different, desperate answer to that one question. Look at the prices they pay. Copenhagen says a measurement just collapses it, and then refuses to define what a measurement actually is. Objective collapse theories add a brand new physical force that yanks the cloud into a point. That's extra physics, testable in principle, and never observed. Many worlds says nothing collapses at all. Instead, the universe splits, so every possible outcome happens in its own branch. Infinite universes forever. Carlo Rovelli looked at all of that and said, "You're paying far too much. The problem isn't the physics. It's a hidden assumption you didn't even notice you were making. The assumption is this, that a particle has one absolute state, the same for everyone sitting out there in the world." Rovelli throws it out. He says the only thing that exists is the state. A system has relative to another system it interacts with. And system does not mean a conscious mind. It's anything physical, a detector, an atom, a wall. When two things interact, each one gains information about the other. The wave function was never a real object floating in space. It's the information one system holds about another. Collapse is just that information being updated when they touch. I know that sounds like a word game, so let me prove it isn't, by showing you the paradox it kills. This is Wigner's friend, and it's a real headache for almost every other interpretation. A scientist is inside a sealed lab. She measures a particle and gets a definite result. Let's say, up. For her, that's a fact. The thing happened, done. But her colleague is outside, and he hasn't interacted with any of it. As far as the physics goes, for him, the scientist and the particle together are now one big superposition. Both outcomes at once. For him, nothing definite has happened yet. Now watch every other interpretation squirm. Did the result really happen when she measured it, or only when he opened the lab? Was she herself, her thoughts, her memories, in a superposition until he checked? Who is the real observer? Copenhagen can't tell you. This is exactly the kind of question that has no good answer, as long as you assume there's one absolute fact of the matter. Rovelli's answer is almost insultingly simple. They're both right. The fact the particle is up exists relative to her. It does not yet exist relative to him. There is no contradiction because there was never supposed to be a single observer-independent fact in the first place. The paradox wasn't in nature, it was in your assumption. And look at what dropping that assumption buys you. No conscious observer doing magic, no new collapse force bolted onto the equations, no infinite branching universes. You change one assumption and that states are absolute, and the deepest puzzle in quantum mechanics just dissolves. That's not a word game. That's a theory doing real work. And here's why you shouldn't dismiss it as a trick. Physics has pulled this exact move before, and it won. Think about velocity. You're on a train going 60, holding a ball. To you, the ball is perfectly still. To someone on the platform, it's flying along at 60. Who's right? Both. Velocity was never an absolute property of the ball. It's a relationship between the ball and whoever measures it. Now here's the part people forget. Around 1900, physics had a genuine contradiction on its hands. Maxwell's equation said light always travels at the same speed. Newton's mechanics said speeds simply add up, which made that impossible. A hard contradiction between two pillars of physics. Einstein's fix wasn't a new force, it was relativity. He took something everyone assumed was absolute, simultaneity, whether two events happen at the same time, and made it relative to the observer. The contradiction vanished, and we got special relativity. One of the greatest leaps in the history of science came from relationalizing something people were certain was absolute. That is Rovelli's bet. The quantum state is the next absolute we have to give up. The measurement problem is this century's Maxwell versus Newton, and relationalizing it dissolves the paradox the same way relativizing time did. It isn't a wild guess, it's the most successful strategy physics has ever had. But the strategy has a price, and you have to stare it in the face. If Rovelli is right, there is no objective world underneath it all. No master copy of the facts. The universe isn't a collection of objects with fixed properties. It's a network of interactions. Things don't have properties on their own. They only have them when they touch. You are not standing outside the world watching it. You are one more node in the web, and the only facts you will ever have are the ones that exist relative to you. And that is the fair objection. Critics say Rovelli buys his tidiness too cheap, that every system has its own facts quietly gives up on explaining how all those perspectives ever knit together into one shared world. Maybe he dissolves the paradox by dissolving reality itself. That's a real debate, and we'll come back to it. But you can't deny what the theory does. With one assumption gone, the measurement problem and Wigner's friend both stop being mysteries. No magic, no extra universes, no new physics. Whether that's a triumph or a cop-out, that's the fight. And if you think that was a bold move, wait for the next one. What if the wave function isn't out in the world at all, but literally inside your head, a measure of what you expect to see? That's cubism in episode 2, and it goes even further than Rovelli dared. If this rewired something in your brain, subscribe for the full series and tell me in the comments. Did Rovelli solve the problem, or did he just define it out of existence? I read everything. See you in the red hot.